Lesson P.5, Solving Equations Graphically, Numerically, and Algebraically. In this lesson, we're going to focus on solving quadratic equations by using the quadratic formula and completing the square. We'll discuss and review how to use a graphing calculator to find the zeros of a function or to approximate the zeros of more complicated functions together in class. The zero factor property, also known as the zero product property, tells us that if we have two factors being multiplied and our product is equal to 0, that implies either the first factor is equal to 0 or the second factor is equal to 0. We use this property when we're solving quadratic equations or polynomials by factoring. The most common type of polynomial we work with is the quadratic. A quadratic equation in x is one that can be written in the form ax squared plus bx plus c equals 0. A, b, and c have to be real numbers, and a cannot be equal to 0. If a was equal to 0, we would no longer have a quadratic equation. Now we're going to review the quadratic formula. We can use this to solve a quadratic equation. If we can identify what the a, b, and c values are of the quadratic equation, we just have to plug those into the formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. The quadratic formula is something you have to have memorized now in pre-calc. The other method for solving a quadratic equation that we're going to review is the process of completing the square. There's a couple of conditions that have to be true if we're going to use this process. First, the leading coefficient has to be 1. The number in front of x squared has to be 1. If it is not, then we have to divide that whole equation by whatever coefficient is there. Also, we're going to isolate the x terms on one side of the equation and the constant on the other side of the equation. Once we have that, those two steps taken care of, then we can go through the process of actually completing the square, which we'll go through in a couple of examples later on. First example, we're going to use the quadratic formula to solve the equation y equals 2x squared minus 7x plus 5. We can see what the a, b, and c values are. Our a value in this case is 2, the b value is negative 7, and our constant c is 5. So now we just have to plug these values into the quadratic formula. X equals the opposite of negative 7 is a positive 7, plus or minus the square root of, whenever we have a negative number, we need to make sure we put it in parentheses if we're going to square that quantity, minus 4 times 2 times 5. And then that's all divided by 2 times 2. Doing some simplifying, 7 plus or minus negative 7 squared is 49, minus 40 is going to give us the square root of 9. Okay, 4 times 2 was 8, 8 times 5 is 40, so 49 minus 40 gives us 9, divided by 4. This actually simplifies down nicely because we know the square root of 9 is 3. We have 7 plus or minus 3 divided by 4. 7 minus 3 is 4. 4 divided by 4 is 1. And then 7 plus 3 is 10. 10 divided by 4 simplifies to 5 over 2. So our two solutions in this case are x equals 1 and x equals 5 halves. Second example, again we're going to use the quadratic formula to solve this quadratic equation. Y equals negative 3x squared plus 12x minus 7. The a value is negative 3. B value is 12. And our constant is negative 7. So plugging these into the formula, we have x equals negative 12 plus or minus the square root of 12 squared minus 4 times negative 3 times c, which is negative 7. That's all divided by 2 times -3. Now we have some simplifying to do. -12 plus or minus the square root of 12 squared is 144. We have -4 times -3 times -7. Well, -3 times -7 is going to be a positive 21. 21 times -4 is going to be -84. 144 minus 84 leaves us with 60. All divided by -6. The square root of 60 we can break down into radical 4 times radical 15. So that simplifies to 2 radical 15 all over -6. Looking at all these terms, they have a factor of 2 in common. More specifically, they have a factor of -2 that we can take out. So if we take a -2 out, we'll be left with 6 plus or minus radical 15 all over 3. Now, some of you might be wondering, why do we not have a negative out in front of this 15 if we took a factor of -2 out? Well, if this was a negative, these signs, since we have the positive and negative above that, they just negate each other, so we're going to have the same result in the end anyways. Now we're going to go through a couple of examples of using the process of completing the square to solve a quadratic equation. So if we have y equals x squared minus 8x plus 17, first step to solving this, replace the y with the 0. So we have 0 equals x squared minus 8x plus 17. When we're going to use the completing the square process, there's 2 conditions I said we have to have. First, the leading coefficient must be a value of 1, which it is. Then the second condition, we need to isolate the x terms on one side of the equation and get the constant by itself. So in this case, I would subtract 17 to the other side of the equation. -17 equals x squared minus 8x. And I'm actually going to rewrite this as x squared minus 8x equal to -17. It's probably just easier to learn it with our x terms on the left side of the equation. Now we need to add a value of b over 2 quantity squared to both sides of the equation. So I'm going to add, my b value is -8. So I have -8 divided by 2, that quantity squared. If I add that to the left side, we have to add it to the right side of the equation as well. The reason we add that value is because it's going to create a perfect square trinomial on the left side of the equation, meaning this will factor into some binomial squared. So we have an x squared, we know we have x in the middle, our b value is negative, so this is going to be minus. We take whatever this b over 2 value is, so 8 divided by 2 is going to be 4. So we have x minus 4, that quantity squared. On the right side of the equation, -8 divided by 2 is 4. 4 squared is 16. So -17 plus 16 is -1. Now we can go through and solve for x. We take the square root of both sides of the equation. On the left side, it's going to cancel out, leave us with x minus 4 equal to, we have plus or minus the square root of -1, which is I. Last step, add 4 to both sides of the equation. We get x equals 4 plus or minus I. So one solution is 4 plus I, the other is 4 minus I. In this last example, again, we're going to use completing the square. We have 2x squared plus 7x plus 12 equal to 0. In this problem, there's a few things we have to do first before we can use the actual process. Our first issue is that the coefficient in front of x squared is not 1. So now we have to divide this whole equation by 2. If we do that, we'll be left with x squared plus 7 over 2x plus 6 equal to 0. Now we have to get the x terms isolated by themselves. So I subtract 6 to the other side. Now we have x squared plus 7 over 2x equal to negative 6. Once we have these x terms isolated by themselves, we can add the b over 2 quantity squared. So I'm adding b over 2. So I'm taking 7 over 2. I'll show this off to the side. 7 over 2, that quantity divided by 2. I can think of dividing by 2 as 2 over 1. So I have a fraction divided by a fraction, which means I can multiply by the reciprocal. So I have 7 over 2 times 2, times 1 over 2, the reciprocal, which will be 7 over 4. So back to the problem, when I'm taking b over 2 quantity squared, that turns into 7 over 4 quantity squared. If I add that to one side of the equation, I have to add it to the other side of the equation as well. The left side, now this is a perfect square trinomial, which means it will factor. It's going to factor into x. Our b value is positive, so we have plus. The value that goes here is our b over 2, which in this case is 7 over 4. So we have x plus 7 over 4, that quantity squared, equal to, if I take 7 squared, that's 49 over 16. So I have negative 6 plus 49 over 16. We need to simplify the right side of that equation. So we have x plus 7 over 4, that quantity squared. Negative 6, we have to multiply that by 16 over 16. So negative 6 over 1 times 16 over 16. Well, 16 times 2 is 32. 32 times 3, this will be negative 96 over 16. If I take negative 96 over 16 and add to it 49 over 16, this will be equal to negative 47 over 16. Now we can solve and try to isolate x. Take the square root of both sides of the equation. That will leave us with x plus 7 over 4 equal to plus or minus radical negative 47 over the square root of 16. Reason I break that apart, the square root of 16 will simplify down nicely, so this is plus or minus the square root of negative 47. We can also break that apart. That is the same as the square root of negative 1, which is I times radical 47. And the square root of 16 simplifies down to 4. So if we rewrite this, we have x plus 7 over 4 equal to plus or minus I radical 47 all over 4. Now the last step, subtract 7/4 to the other side of the equation. And we're left with x equal to negative 7 over 4 plus or minus I radical 47 over 4. We have a common denominator, so we can write that as one fraction. Negative 7 plus or minus I radical 47 all over 4. That's a quick review of how to use the process of completing the square. Before we can do that process, we have to make sure those two conditions are true. The leading coefficient must be 1, and then we want to isolate the x variables, those terms that have a variable x, on one side of the equation, the constants on the other side. In this lesson, we reviewed how to use the quadratic formula as well as the process of completing the square to solve quadratic equations. In class, we're going to go through how to use the graphing calculator to find the zeros for quadratic functions and other polynomials. We're also going to use the calculator to find approximations for zeros for more complicated functions.